Okay, so thank you very much for coming to the conference. This is the first conference here in the course on software architecture. The conference is software architecture people of other uses given by Iván Arrizabálaga. And for me, it's really a very great honor to invite Iván. I mean, he was a previous student. We met later a lot of times. He was a student here. I think he has a very interesting and professional trajectory. I really think he will explain a little bit about how it has been evolving, and I think we can have a lot of good lessons from this period. So my advice for you is that he told me that it is not just listening and it's not also just a lot of technical things, but also some even personal things. So my advice for you is to listen to him, and also if you want to do any kind of question now, just do it, please. It is quite open to those questions, and maybe you will learn a lot of things. So,
okay, I don't know exactly how. I don't think they might make this needed. Okay, so this title, software architecture people and other users, is exactly what happens when you don't know exactly what you want to say. I made one of these presentations like 2 years in the past, and I always focus on one very specific topic, and it was easier for me to come up with the proper presentation. In this time, it has been a little bit different, because it's like I end up thinking that it would be like more useful for you to make this mix of different topics, talking a little bit about architecture, but also my own experiences and different roles that I played, but not because of me, but because of all the learnings and all the difficult things that I've been through. And then I will tell you about the challenges that we got in JOOR, my current organization, and how are we dealing with this really important challenge. Just like Jose said, just interrupt me, raise your hand, ask questions. That's the most interesting part of the program. Okay, so we are going to set some kind of basis about what's really software architecture, as always agreed, and then I will show you just a picture to reflect the problems and challenges that JOOR has, and tell you a little bit of what JOOR does. And then I will navigate through some of my learnings on all the different positions that I've been, and we will revisit some of the architecture myths. There are so many things that you are going to read and listen from different people, and everybody feels like the owner of the truth, and it's like it is not. Yeah, so that's pretty much. Okay, so let's start with the most boring. First of all, I promise I won't be talking for, so don't be afraid. I assume that you will have some free time before the end of this. So what's software architecture? Let's start with the most boring definition ever. Software architecture is the set of structures needed to reason about a software system and the discipline to creating such structures and systems. Okay, I'm already sleepy. I don't give a shit. It's kind of real, but it's not really very big. Another even more prestigious definition. The software architecture of the system represents the design decisions related to the overall system structure and behavior by the Carnegie Mellon University. It must be true because it sounds really important. I don't give a shit about this definition, and this is the one that I love the most. It's coming from Ralph Johnson, is one of the collaborators of Martin Fowler. If you are not familiar with Martin Fowler, basically the one is if you just have to read one blog, technical blog, it is. and it says architecture is about the important stuff, whatever it is. And that's a really good definition. We will get into the details later, but basically it's like the general structure of your system, and sometimes it is not so clear where are the lines to define the architecture of your system. Okay, so knowing that the architecture is whatever that is, the important stuff, what is the important stuff for JOOR, the place where I'm working? Well, just 60 seconds of self-promotion. JOOR, what does it do? Basically, JOOR is the wholesale platform to connect fashion brands with fashion retailers. In other words, it's where Versace and Armani and Porsche sell their goods to the main distributors of. It is not a super big organization. It's made of 200 and some people, and we are distributed all across the earth with offices on the hottest markets for fashion. For instance, Milan, London, Madrid, New York, Tokyo. But we got people in many different remote positions. For instance, the team that I manage is made of around 30 people today. It's made of 3 different teams with people from most of the people here in Spain. We got 2 from Asturias, 1 from Coruña, another from Catalunya, another 2 from Valencia, 50 people in Madrid, and then 1 in Serbia, 1 in Berlin, 1 in Shanghai, 3 people in Uruguay, and so on and so forth. Well, and people in Philadelphia and New York City. So it's like quite a complicated topology to deal with. So, okay, if you like passwords, the first, I just started working at JOOR 10 months ago, 11 months ago. And one of the first questions that I made was, hey, can you share a picture of the current architecture of the system? And the answer was like, what? No. Well, maybe there is a presentation from 2 years ago. I'm not sure. Let me check. Blah, blah, blah. So it took me a while, and we ended up finishing this picture. It could be worse. That is quite scary, because in the beginning it's like, what? I mean, really? For just a website to sell t-shirts and trousers and all that shit? Yes. So through this presentation, and specifically in the end, I will try to dive into this picture with you, and we will try to spot the main problems that this architecture has today, and what are the initial steps that we are taking in order to make this better. Okay. But if it looks like reasonable, or the problem is reasonable. There is one principle that after all these books and works and things, if there is something that you have to keep on your mind, is that if your code is hard to change, that's the old part. There might be other metrics, and you might get lost into the books, but really, if your code is hard to change, it's your part. And the addendum, this sentence is your code is going to change. Doesn't matter what you do or how smart you think you are. In the end, the requisites are going to change, and everything is going to fall down, and you will have to revisit all your decisions. So you have to ensure that your code is going to be like quite easy to understand. Okay, so from people to code. This is a very important law. It's interesting because it comes from the 60s. In the 60s, like, there were dinosaurs. And for whatever reason, it didn't become popular until this very year. I mean, it was not even mentioned when I was studying. It was not even mentioned. When I was reading books in 2005, 2006, 2010, it was not really mentioned most of the. That is one of these key principles that you have to keep in mind. And it says, any organization that designs a system will produce a design whose structure is a copy of the organization communication structure. Always wrong. And in the end, what it says is that if you are doing a system with a bunch of colleagues and you organize the work in different pieces, like distributing the work across this bunch of colleagues, the design decisions are affected by the structure of the human relationships of that bunch of people. That's pretty much it. And it's so true that it's not. So we end up with this conclusion, which is the architecture depends on the team structure, which depend on the collaboration flows between the human individuals in these groups, which depend on the human experiences that those guys might have had in the past. So you might be setting an architecture for a system in a whiteboard, but in the end, if you don't put the right guys on the right teams collaborating the right way, you are going to end up with a different architecture. That's like a hidden truth. So that's my excuse to talk for the next 10 minutes or so about some of the learnings and experiences that I have had myself. And I'm doing this basically because those were the reasons that shaped the way that I approach software development. So, okay, some cute pictures. I was from the 1979. I started programming when I was 6 or 7 years. Not really like big things. That I was programming with this Spectrum 48K. I don't know if maybe you have computers. And I have always looked like a computer engineer. It was a really quick decision for me to become a software. One advice is that time goes by like super quickly, and one moment you are sitting in that chair just listening to some random guy, and you go through different stages. So basically, completed my bachelor in computer science in 2002, the master in Gijón in 2005, and I even started the PhD program in 2007, but never finished. Never finished the program because I'm not interested. But it was an interesting job. And some more cute pictures. As I said, time goes by very, very quickly, and you end up with babies somehow, those babies grow up, and then you end up with cats. So basically, what I'm saying is that whatever you are learning now, this is important, and you will have to know that you will keep on learning things forever and ever and ever. It is a never-ending. You better enjoy the whole learning experience, and I can promise that years will pass by. Okay, so this is another principle that I have. Basically, you know nothing, I know nothing, and you're always learning, as I said. When I finished my studies in Japan, I started reading about the different choices for growing a career, and I was always trying to make myself a decision between becoming an individual contributor, it's just a guy 100% focused on the code, or eventually becoming a manager. And I have always been swinging back and forth between these two different types of responsibilities, and I think that that's a very interesting approach. In fact, one of my strong opinions is that in time, that kind of progression will become more and more common, rather than just picking up one choice, making one choice after 2 years of programming, which is now the standard of the industry is that you have to program for a couple of years, and if you are a good worker, you will end up being the team leader, and as a team leader, maybe an engineering manager, and so on and so forth, and then you're a manager. Or you have to be the super techie guy that sticks with the code forever and ever and ever. that's not the best approach, in my opinion. That's not the best approach, because if you have the chance to swing back and forth between programming and managing people, the more you program, the better manager you are, because you will understand the problem that. And if you have the chance to be involved in business, that is going to help you making better decisions for it. So it's like the other way. So basically, I started here in the University of Oviedo as a researcher, working with CISAP and doing some data-related projects. And the architecture that we had back in the day, it was just one CISAP program that did everything. But if there is something that I learned that was very important, is that being able to work in English is key. So I congratulate you all for picking up this path in English, because that's the way. I mean, you can easily double your income just by speaking it. So that's something that I'm gonna share in the next session in Spanish. Is what the hell are you doing studying computing in Spanish? It doesn't make sense. So that's a very important thing. The other thing is that when I was studying, I always thought that being a teacher would be like pretty cool. I don't know exactly why, but it was like, hey, it gives you the chance of keep on learning things and sharing those learnings with the rest of the guys. And it's like a never-ending loop of learning and sharing. But it's quite hard. So for these guys like Labra or Redondo or all these guys, like, it's a tough decision, because there are so many choices, and the university is not an easy task. Good for them, and I'm glad there are people making those. I was in Capgemini for 3 days, literally, and the best lesson that I can take out of that is that if you don't feel comfortable with something, don't stick to that. Don't force it. Just say no and move on. And don't get me wrong, I mean, Capgemini have like, what, 50,000 employees? 50,000 employees is like fabulous. And I have a ton of friends who have been in Capgemini for years and years. So it's not like the worst place on earth. It wasn't the place for me. So once you have the opportunity to move on and start working on any place, if you don't feel like, there is always a certain degree of suffering that you have to bear. Okay? But if you stay in one place and you are learning nothing and you don't feel okay, then if you are like a misfit, just say no and move on. There are so many opportunities that it doesn't make any sense for you to stay in one place for years just because you don't feel good saying. So then I had the chance to work in Neometrics. It's no longer a name, but back in the day it was like super popular here in Spain, because it was the very first data artificial intelligence related company in Spain. Basically all the data related projects on the early 2000 were done by this company, which was funded by student people. And I was there for a couple of years, data consultant and project manager, and we end up working with amazing people. This is very important. Try to find nice people to work with. That's one recommendation. But I also fell into the trap of working long hours, and that end up pay a price for society or all those. So it's like, it's such a stupid thing. I mean, there were for months I was working just because I was so stupid, from 8 in the morning to sometimes 10 at night. It was like 11 hours a day. And it was not because my bosses were with the whip saying, it was like, hey, is anybody who can help with this shit? And I was, and I ended up, it was a disaster. So just take care of yourself. While you're working 100%. While you're not working, just take a pause, rest, get about to work. So then I moved on, and I made this is where I really moved from making code to being more involved in the business I was the manager of a division, business case in this. This is the consultancy of the important West. Now it's called because it has changed. But back in the day, it was the most important consultant company in Spain, and they were made of 3,500 people. So it was an independent company from the whole corporate West group, and we were making all the e-government websites of us. All these Julia.es, the tourism site, the justice site, the culture site, this kind of thing. So I started dealing with this team just made of 4 people, and I end up managing a team made of 35 people and dealing with everything from end to end, from the business presentations to the budget, to some reviewing some technical decisions, hiring people, giving talks, all that shit. From the architecture perspective, the one advice is that we end up selling lots of solutions depending on vendors. It's like there are solutions that there is a commercial vendor with one solution and you just implement that solution. And from the technical perspective, that's not very interesting because it's like repeating yourself over and over again. So it wasn't the best place to learn about technical stuff. But I learned about some of the stuff. So, I learned how important it is to get the big picture of the whole business. And it's like we as computer engineers, we most of the times underestimate the importance of understanding the business. It's like, I don't care, what do you want me to do? I can do it because I'm so smart, I can program. You're so stupid. I mean, you need to understand the basics of the business in order to make better decisions, and in order to help the product managers and the business people to prevent them from doing silly stuff. So that's my advice. And on the other thing, people is super hard. Dealing with all this trading at times is deterministic. But dealing with people is like the most passive, random shit that you will ever face. It's like, what? I mean, there might be some relationship between the root causes and the consequences while dealing with group of people, but it's not so clear like tracing or the moving it is just up. My advice from here is to try to stay hands-on. By hands-on, I mean try to find some time to understand really the technical side of the business and try to take care of your to stick and stay hands-on is very important because in the end, if you just link yourself to the management end and forget about all the technicals, you cannot be involved in the real conversations anymore. So you're just walking on air, trusting on whatever opinion the rest of the country, and you cannot be very useful to those things. Okay, so basically I quit. It was a weird decision because I was like quite young. I was in my 20s and I was already having to manage these large teams of people. So supposedly I was supposedly succeeding somehow, but I felt like shit, honestly, and I was missing like programming a lot. So I decided to quit and become a freelance and start working as a software architect with a startup from some friends of mine. And I did for 4 years some of the best software that has been built, or at least that I'm aware of here in the we built few products that were used on the markets, and they were kind of crazy. One is that from the architecture perspective, we were still using this MVC approach with fat models based on Groovy, Grace, and those technologies. But the important piece is that working in small teams is way better. You have the opportunity to work in a small team with lots of responsibilities, making real decisions, just becoming part of a group of people. That's where you're going to learn we solve pretty complex problems. But the point is that the project didn't really succeed because it is not just about the code. It's the code and the business which, if you ever consider to become a founder, one of the things that you have to take into account is that you have to build good stuff, but you have to also ensure that you have the right reach. So I quit and I started freelancing just for a year, making mobile applications for a startup which was helping non-profit organizations. Typically, they were creating a mobile application to control the spread of infectious disease on third world countries like malaria in Asia. And what I learned from that is that from the architecture side, it was only for Android, like very, but I really think that the purpose matters. So one additional tip is that if you have a chance to make a choice between a few different options when it comes to working, and one is more aligned with your heart, with your heart, stick with that. Because if the difference is very small, you will feel so much better working with something which is meaningful. Is a very good thing. And I also started working remotely, which is very important. I'm quite obsessed with communication, the async way of life. So you can make your own schedule. You don't have to stick from 9 to 5 on a given office space. It gives you lots of freedom. You can do a bunch of other things, and you can be like super efficient working remotely if you. So then I started. I don't know how, but I ended up founding my own company. It still exists, even though I'm not related to the company anymore. And it was some of the most interesting years of my career. Basically, we started from scratch. We were just 2 people and 40 people with contracts signed with Microsoft, with money getting cut from the European Union. Yeah, I ended up doing a bunch of crazy. I personally made the first versions of the system, and then once we have a bigger team, I end up with different responsibilities, taking care of some part of the business. When it comes to the architecture piece that I experienced here, we moved from a super simple MVC for the team back in the early 20s to what I call a citadel. I'm mentioning here one article from DHH, which is like the one in charge of rails. He refers to the citadel as this pattern where you might have like one monolith, just a few services that are well decoupled from the monolith, allows you to grow the system without falling into the trap of creating 1,000 micros. It was, as I said, it was a great experience, and I ended up quitting just because I was not aligned with the future of the. I thought that we should become pure SaaS service. The rest of the founders thought that we have to stick to our ad-hoc consultant way of working. It was not interesting. So I made another change, and this is the penultimate approach. For 2 years, I was the head of analytics in Click Dimensions. Click Dimensions is a company which is like not very well known. It's like super profitable, and it is a mid-sized organization, 250 people, with people all around the world. And I end up managing guys from Israel, from Spain as well, from Russia, not Russia, Belarus, from Ukraine. The learnings are working with US organizations, remote class is an opportunity because they are very, very and it's very important for you to create a vision. If you eventually get to a management position, I think it's very important for you to not just deal with the daily basis, but also try to create a vision of what's needed for the organization to change, write it down, share it, so you can make like a plan to become that aspirational organization. On the other end, other things that I learned, it is very important to be able to set a rhythm to your teams. Rhythm is like, for instance, while you are a student, most of the times what you do is like, hey, tomorrow I have to deliver this practice, this. So the day before or the 2 days before, I make like a huge effort, a big push to make it happen and deliver that thing. While working, this is not going to take you very far. It is way better to find a sustainable rhythm across the different days, weeks, and months, so you can keep up with that pace and deliver consistent. Because otherwise, you will end up working very late at night, and you will get. Okay, so finally, this is how I end up working in JOOR as the director of engineering. From the architecture perspective, what I've learned is that the microservices are super fun. From the right side, I love JOOR because I love the people that I'm working with. I fell in love from the first interviews. Once I decided to quit 3 dimensions, I just made like 2 or 3 interviews. All the possibilities were like super interesting. This is the one where I fell in love with. They are just great. They got lots of vision in the good sense. We want to do the right things, make this bigger, to grow this opportunity as much. And we got tons of freedom. It's not such a problem when you join an organization made of thousands of people. Is that okay? So you are the engineer number 10,116. So can you make an impact? Yes. How much impact? Well, if you join an organization made of people, everything that you do, you have to be and you can be one of the important positions. So that's very, very interesting from the growing. And the only challenge that we have is that we don't have infinite resources, people, infinite. So we need to be very, very picky when choosing our battles, trying to, okay, so these are all the problems, all the things we can optimize, but we cannot try to make them all happen in one shot. Because if we do that, we will just get frustrated. So we need to be very picky, selecting the battles. Okay, so this is a summary. This is the ending of the people piece. The things that I love of my suggestions is, congratulations, you're already making English. Let's stick with that. English is important. Just say no, don't fit in this. That applies for important. Prioritize working with amazing people. Have the opportunity to join some teams. That is going to be great. For when it comes to the downside, or the other side of the coin, just draw a line in the sand. Hey, I don't want to go beyond this one. Stick with that. Don't work super long hours. I'm not saying don't put effort. Working for real 8 hours a day, every day, it's like super. I don't know exactly how others are supposed to work 8 hours a day. I don't know who decided that 8 hours was a reasonable amount of time. Because honestly, I doubt I can make 4 or 5 real good hours a day of fruitful work, but it's fun. So take care of your own health. Try to stick aligned with the purpose of the organization, and just select the right path. Don't try to fix everything around. Moving on. Questions so far? Again, we will forget about architecture myths. This is the summary of all the articles on internet, Twitter, YouTube. The summary is monoliths are bad, microservices are good. That's it. You put a tattoo on your shoulder with that, you are good. You become a member of the tribe. You are on the good part of the history. Really? The architecture goals, and I will try to make them as easy as possible. There might be others. There are books about the architectural goals, thousands of books. And I would say that the only three that stick around my head are: the code needs to be easy to change, your code needs to be easy to test, and your code needs to be easy to deploy. Period. It seems like reasonable. And from the history perspective, and I'm sure that you're gonna, if I'm not wrong, you're just about to start this whole subject, so you're gonna get through this in detail. The pictures are not mine. In fact, are the first ones that appear if you look for software architecture on the internet. But the message is in the 90s. I'm not saying that all the code in the 90s was made of copy, paste, and approach. That's not real. There were lots of that. The only important piece was to make things work, regardless of anything. It was not like I was like super involved in the industry, but I was using some of the products and I was reading books during the 90s. Testing was not really even a thing. It was more like a manual thing. So the approach was quite different. In the early 2000s, we moved from this STL code to this lasagna code, where basically everybody was forced by the frameworks to work on layers, and you got the repositories, services, products. That's it. And you stick to that plan, and it doesn't really matter how big your system was. You always end up with the same structure. It was kind of good for some things because you can move from one project to another like very quickly, but it was like quite stupid for other problems because you cannot try to solve all the problems with the same solution. It doesn't really affect. In fact, it's like eating lasagna every day. I mean, I love lasagna. I need to eat other things. So slowly the trend moves, the thread needle moves to different place, which was microservices. In this picture, they said ravioli, basically because these are made like a pretty big but not super big pieces that can relate to each other. But I think that microservices was really not well understood by the industry. We all have committed lots of mistakes trying to apply microservices. Lastly, what it looks like, and this is where I don't know, we're slowly moving into this serverless world. I don't know if that's going to be the solution for everything. You have to take in mind that there are many systems that doesn't even require a need of serverless is based on one premise, which is that everything is going to well, this is tricky to know exactly what the architecture is going to go, but this is like the most general. Okay, so let's make a couple of draws. Okay, so basically we said that there are monoliths, there are microservices. And I'm just going to focus on this. The monolith is like one self-explanatory. It's just like most of the times you have that connects to a real server. The microservice is more like, okay, you have a that connects to maybe some kind of an API gateway, and connects to different, so it depends on the services, where each one need information. You end up with something like, what are the problems of the monolith? The problem of the monoliths is that in most of the cases, code inside this big system of the server lacks good structure. You end up making like lots of different calls from one place to another. If there is one team made of, let's say, 20 people working in this piece of code, the chances for you to make to end up making stupid decisions are very high. And the other problem is that when it comes to shipping, deploying this solution and scaling the solution, you only have one shot. So you have to scale the whole thing, regardless of the program. Maybe just have maybe you just have a portion of the system which really requires scaling. You have to scale the whole thing because everything is broken. So one of the benefits of the microservices supposedly that all these services will be scaled and managed independently. You can stick. You remember my people working in smaller teams. Goal of microservices is of, okay, so I got a team made of 5 people in charge of this one. Have a team of 5 people in charge of this one. These are like 5 decoupled and independent functionalities of the system. So it's like they don't give a shit about each other, and they can be running and deploying solutions, different cadence and different solutions. So basically, this opens up an opportunity to say, okay, out of this system, the only piece which really requires scaling is this one. Is this one. And you can make this particular service big onto the containers or the infrastructure big as needed. This is more cost efficient. Okay? And all of this comes with and with some risk. If I move down, there are like 2 different versions of these 2 architectures, which are not so well known. And one, I would call it the modular monolith. And here, I'm going to call it the real. I'm going to stick to the distributed model. Okay, so what's a modular monolith? Modular monolith is a again, it's one big chunk of code, and that big chunk of code connects especially to. But the internal organization of this big chunk of code is made of modules. These modules, the architecture of these modules are like very well decoupled. Each of these modules has some rules to communicate to the rest of it. So in this case, this comes with a few advantages. First, deploying this is still super simple. And there is no need to orchestrate the changes between different services. It is easier to test basically because it's like everything is in one record. There are strong rules that prevent one module to infect other modules. So you have a decoupled. This is a very good solution for most of the problems out there, but it's not really for whatever reason. And when it comes to the distributed modeling, pay attention to this because it's very the chances if you move to a work where they say they are working with microservices, chances are they are working with something. Okay, you got a few services, maybe you have something which is bigger, but you know what? These two are connected to the database, and sometimes these two as well, and this has a database, but this one, this one, this one, and yeah, we end up knowing that this. So this is distributed monolith because in the end, when it comes to the server, you for sure have different services and you can even different teams working on different pieces of it. But these pieces are so tightly coupled together that you have to deploy them on sync, you have to test them on sync, and even they are connected to the same database. So when it comes to the different data migrations in here, you have to be on sync with the different teams because you are affecting lots of people. It's not just the 4 guys working in this piece of the system. You are also affecting the guys working in Uruguay or the guys working in Germany because you are bringing another column. Okay. So this is most of the cases where people say that they got microservices architecture, they got this, and this is the most problematic because it has the worst. All right, so that's pretty much everything I wanted to reach. Make sense? This is like a joke. So true. And it's aligned with the next message that I would like to. I don't know if you're familiar with this. Raise your hand if you have seen this. So basically, I don't know. Do you know this? So basically, what it says, it goes like this: the Dutch government had to publish their code for some kind of authentication problem, and they got this UI widget when they say, okay, according to a certain percentage, these are the goodness of your password or something. And the code was turned into a meme because it was like this. In just a little. Okay, so the original code was like this. You get a double, and you just check depending on the number how many dots you want to. So the first impression was like, oh, I'm super angry because all my money is being used to build this super shitty code, and my taxes are not being used right, and so on. It should be a much smarter solution. Okay, right. So people end up with these type of solutions, which are more difficult to build. And even this particular solution, which is like kind of crazy, it's very difficult. It's incredibly difficult. So basically, what it says in this picture is that you go through this normal distribution where in the beginning you think like you're stupid and you push your heart to your boundaries, to your limits, in order to see to discover that, hey, I'm super smart, I can do this in 2 lines and so on. But in the end, you know what? If you might end up being in a Jedi mode, being started thinking, okay, maybe readability is more important than being smart, and anybody can read the function, and it takes like a millisecond to understand exactly what it does. So maybe this is not a bad solution. Okay? So that's basically a good example of my philosophy. And this is where, and I'm saying this because I'm saying this on purpose, but I don't really mean it. Like what I'm saying is that some basic coding principles are more important than the super architectural decisions are taken in a hidden room. So you might end up with a super nice diagram of your system. And if the code inside those boxes are made of crap, your system is crappy system. The other way around, someone might ask you, hey, what's your architecture? You shall then see this a reactive solution is based on microservices with services. It's like, well, no, it's just what we needed. It's made of these pieces. Yeah, but that solution doesn't stick to a plan, doesn't stick to one of these routes or trends. You should not give a shit. You have to come up with a proper solution to your specific problem, regardless of the shape of that solution. Okay? So my general principles and recommendations is to really have a deep understanding of the business problem that is going to allow you all to simplify the solution. And that's so much needed. Always prioritize the readability of the system over other considerations. Readability always wins. Always try to decouple the different domains of the system. By domains, I mean the main functional chunks of the system that might work in isolation. If you can do that, decouple the behavior of these domains, you will be good because your system is going to be easier to always stick to this single responsibility principle, regardless of the level of granularity that you are working on. And my last recommendation is to try to get used to using TDD, because TDD is not about testing. The testing piece is just a consequence. The most interesting benefits of using TDD are two. One, it forces you to create well decoupled systems, because if you don't decouple the solution, you are going to struggle creating the test. So it's one way to force you to decouple units. And second, it's going to bring like a documentation to the different pieces of the system, because test basically is a contract of the behavior of a given piece. It comes with lots of. All right, so this is the last piece. The JOOR way and challenges. If you remember this crazy picture, what I would like to do with you now is to open this picture and try to draw the general pieces of it, make it more readable, and I will ask for help, try to identify the problems that we have, and from there I will share what are the next steps that we want to do. Okay. So, we'll zoom just a little. Basically, the colors mean that we got some third-party services, we got some resources related to infrastructure, some backend services, some authentication related pieces, some what the fuck is it? What's this? Nobody knows. You have to take into account that JOOR has 210 code repositories. So we got like lots of pieces, and all these pieces need to fit together. So, yeah, that's why we started just. So basically, what we got is like this. We got a set of we can a bunch of pieces related to the authentication. This is all about because you have to ensure when you get these all these services, you have to ensure that the principal and user making different requests is authorized. So all these boxes are related to a super complicated authentication solution, different services, and like that. We have these which are like the UI parts of the for the clients. We have different flavors for this. As clients, we got iOS applications, we got a React application, front-end. We still have some of the pages of the system are still on old PHP related code base that want to move away from that. But we still have, we got the UI, we got the authentication, then we got
the whites.
We got 4 mobile apps.
Those are the white apps.
Yes. I consider that not just we got the JOOR React.
How do you do it?
Well, yeah, it's like those were apps, and it's like we also have an API. We can just like we got in the middle, and then we got you remember the pieces that I identified later? I was referring to some kind of an API gateway. We got some of that flavor of. We got one piece here, which is like GraphQL, which is allowed to connect with different backend services, and that building chaos, the mix of different nodes. Are the names of the code. It's like we have like different APIs for one is public and the other is private. There is the same. These are based on Apollo. It's just like mapping inputs and outputs. Then we end up with a bunch of different backend services. Pretty much services over here, which connect to basically one big database. Okay, so with that picture in mind, considering the different architectures that I mentioned before, what's the architecture of this? It is a monolith, microservices, distributed. It is a distributed model. Super problematic. Let me. It's just because we have a public API. We got 2 flavors of API because the system is also integrated with CRMs, Salesforce, of actually manually. We got the GraphQL flavor. We got the REST API. So there are some pieces when it comes to the authentication of this API. We are investigating because it's like, in fact, we got, we're gonna get into that. Well, basically, this is it. We got a distributed. So what are the main problems that we got? We got one, we have one database. This is super complicated because that database is made of more than 500 tables. You really have to change things. The chances for you to break something else. So we need to get rid of it. We still have some legacy code pieces where the topology of the system is not like clean and clear. We need to get rid of those pieces because otherwise it's not going to be easy to change. If you remember, one of my key main principles, your code needs to be easy. We also need to revisit the whole authentication solution we got, because once now all the different communication between different systems still need to go through the authentication piece, and there is no good reason for that. It's just like an overhead for all the traces network relationship. And the last piece that I would like GraphQL. It is not a good solution for the problem, and it was probably the decision was made because it was perceived. Actually, it was a poor solution because it forces you to serialize your data 100 times more. Like, it's not just moving your data from the database to the service for to the client. It's database to the service to the GraphQL server, So you're moving the data. So that's why it's harder for you to have a good performance. So those are pretty much. Yeah, I was just focusing on the main thing. We got other things. We got integrations with different types of services. For instance, we got integrations with 3 or 4 different image services to make things with. We process millions of images. I don't want to say per day, but week. We have to integrate with those services. We also have an integration with payments platform. Before we got an integration with Stripe, now we have an integration with the payment platform. We also have open search solution. All this data is moved from ETL pipeline eventually into BigQuery. On those BigQueries, we build some reporting solutions. Those are like collateral, but those are not so interesting. Another tip: whenever you build up a diagram for a system, be heuristic or super simplistic heuristic to find where is the pain, is the cardinality. And if you just pay attention to this box, you just realize that you have like 12 different arrows hitting that box. That things. Supposedly, you should have like one input, one output figure. The moment that you have like groups from these arrows, that's like a red flag. That's why this is one of the main pain points. This is another pain point. So on and so on. Right. So okay, next. So what we did is that after I joined JOOR, I decided to run a short analysis project on the whole thing because we lacked lots of documentation. It was like there were key guys knowing exactly how a piece of the system works. That's like super risky because if a bus runs through one of these guys, nobody knows exactly how to do it. And we went through that. We end up with the diagram. We end up with a final solution. Is the end of this transition? We decided to define how to get there. The finish line is that today we got a dedicated team to reduce the complexity of the some conclusion. Your system will always have an architecture. Whether you plan it to be a good one, or there is always going to be an architecture. The people and the structure of your teams will affect the solution. Period. It's going to happen, regardless of what the boss is going to tell. The architecture is different from the implementation. You might have a well-defined architecture and still have a poor solution, and you might not have a super well-known architecture, have a good solution. In this sense, try to defer or delay some decisions as soon as possible. It's like, okay, generally speaking, these are the whole solution. When it comes to the implementation details, just wait until you have all the information, because the information is going to change. Like the business guys are going to tell you one thing, and you shape the best solution ever. And while you are programming that solution, hey, you know what? I talked to these guys, and yeah, they don't need this. They need this thing instead. And you have two options. So crazy to be ready for change. So you will be ready for change if you just draw like the main lines and you will try to delay the implementation details as much as possible. And my latest point is working on a refactoring project is way more powerful when it comes to the ability to help you grow the different learnings that you indicate than working on greenfield projects. These greenfield projects usually are great experience. These are like very theoretical, and if you don't have real users using the system, you might have the best software work. Nobody's using. If you have a system with lots of usage and you have the responsibility to reshape it into a better solution, that's the ultimate level of complexity. That's where you are going to learn most. That's all.
So, time for questions. Really, we have not take the opportunity to ask questions. Learn. It has a lot of experience in a lot of domains and he knows a lot of things. Some are interesting. Has been in a lot of places. He knows a lot of things from different companies.
I have a question, but I think it was more concept. You said that the single responsibility problem, what is the meaning of this?
You will only
Most. And you say,
I didn't go to that subject.
the single responsibility. That basically means that each I'm going to make each class, each method will be in charge of it. And this comes with, if you end up having a method with lots of patterns, different combinations of all these patterns will give you different behaviors. Those are different methods. If you are thinking on reusing a piece of code but bringing just one additional method, argument to that method, which is a Boolean, depending on that Boolean, you have an if else on that method, those are two methods. That's it. Basically, the if else in one method, also cascade if else, if else, if else.
You already put it in Microsoft. When you have this process, what's the best approach to communicate any? Maybe like ERCP or making a public API and because
it depends on the nature of the relationship. Basically, there are two natures. Is synchronous communication. The other one is asynchronous communication. We are using DRCPs to communicate between these two services. Top of all the complexity integration, we have these DRCPs, and that's when you need synchronous communication. Those are messages you have to do with those. For many opportunities, the asynchronous goes with a benefit. It's like it's easier to scale, and if you can detach the need for sending a message from this system to another, like, hey, I don't care if this write is done in the same system, it's going to scale it easier, and it's going to be easier to recover from mistakes. Because you just put a message on a queue, and the other system is like producer and consumer. One system has a message with some event that you need to process. Consequence of that processing, they emit other events to other pieces of the system. These messages can be handled asynchronously. So that's quite beneficial. Sometimes the synchronous communication based on DSPs.
Yes. I posted.
One thing that I want to say is advertising. For now, we have obviously businesses. This open kind of we call it private engineer. Anybody who is curious or something, we will be yes.
Maybe you can explain a little bit how is it working in the because when you are working for a company that works in New York, and you are here in this. Which is a big, I mean, you don't have questions, but I think maybe you are curious about that. I mean, it's quite important to explain, and maybe I think you could.
So, first of all, we need to make a distinction between working remotely. Most of the times, remote is about location, busy is about location plus. We are just remote. We are slowly moving in busy. That comes with a big share all the different stakeholders. I think the difference is that working in a simple session, you try to minimize meetings, you try to put everything, we rely on conference, we can also conversations with conference, like, hey, this is my findings and proposal. And rather than trying to find the right slot to join 4 people from 4 different time times, try to have that protocol. We can fix an issue without having a problem. We are kind of lucky. We have like 3 or 4 very good hours of overlap in your office. Basically, then they start around 8 in the morning. It's 6 hours, 2 p.m. for us. Basically, from 2 p.m. to 6 in the afternoon, 5 in the afternoon, those 3 hours, we can finish the meeting. This was morning, don't start working out. Very, it depends on the day. Because I think it's half an hour. So I have to say that important thing for they have to be very, very, in this case, it is. It's very hard then to schedule a call on that moment, like it's 5:30 or 6. Like, hey, I know it's late for you. In other organizations, even here in Spain, I've been working in places where I even schedule 8. I've been working on presentations. Yeah, the one we got one branching program that working with APIs is based on it's like you know that there are early birds and you got Batman. More like
Usually at 4 for us, it's enough for United States and for Australia.
it's quite hard. That's why now we are hiring more people to manage the cameras as well. If I saw, even though I think I'm looking for patient, sometimes somebody needs to review here. If she need to be in contact with the end, someone is in fact we encourage each thing have like pros and a strong advocate of the thing. That's why it's getting comes up. I mean, it's a natural thing. You can share the. This is the struggle. I mean, for years I was like super strongly convinced that I can work your PC. Now I'm starting to value the daily experience because it comes with lots of and you create social connections, you have full eyes, you reduce the amount of you need to be done with your pull request. And it's like you can test, you can craft both into that. It's more
For example,
we can like at least twice a year. For instance, I was in New York last summer. We here in Spain we organized some well, we got a budget, monthly budget organized. It's not like now we have this, we want to make us take a track. 3 4 months or so, but basically the Spanish guys were the ones in sense March. We will be the CEO is flying here in Madrid. He's in Serbia, Berlin, flying as well to Madrid. So there is a mix of
Pros working experience. Like it's tasting.
those.
And the question is, wouldn't that reduce the productivity of the you like you're in Spain and we have a PR tool from the United States, you have to wait for the time to they will have to go to
Yeah.
so
That's I think that async communication power and move most of going to be lots of super stupid and get rid of them. You can turn real-time conversations into a conference page that read and analyze those solutions. Because in a real-time conversation, one who talks wins the that's not necessarily best. So giving yourself some kind of force, think about the problems. That said, you still need that type of collaboration. But I think that the best approach it would be like both async first organization with hubs of people working on the same time zones. So the guys in those time zones can collaborate together and lots. Depends on the organization. For instance, Scrum in ultimate work when it comes to AC, we will have some formal student culture working there. We are, I don't think that's possible in AC. We are working in
people.
and one more thing, you mentioned maybe 2 years, we all decide, we will all decide, yes, we're not. In fact, that conversation already exists. This plant-based approach, you're basically pairing with something, with something, just keep your code with the language. There is no peer review. But the peer review comes with lots of problems. I mean, it's got lots of goodness as well. Such my organization today is not ready to. I think that eventually most of the organization peer reviews will exist. Will be in most of the my position.
What do you do with
We still do pull requests. The only thing I'm saying that this is one of those practices. The standard. But there are few organizations running trunk-based development that you have like very strong coding practice. You are always programming, or even mobbing. Therefore, you have TDD and you have all your section pipeline, you rely on feature flags. So rather than having a non-leaf branches, problematic merge, just work on small increments, just shift those small increments.
what is the branching model? remember this. So I am also in favor of trunk-based development. And I think that pull request, even if you have a trunk-based development, you can have a pull request. You can repeat that.
The once you can engage in what will be your the group-based development. Basically, group-based development, that's their position.
That's very
I have never practiced. Like, listen to, not true.
So maybe. Okay, so thank you very much. The question. Right, because I mean, teachers here at the university we are used to teach 2 hours, 4 hours, but he's going to teach the so any questions? Okay, so thank you very much. You